In this video, I'm going to go over every single topic that could appear on your Algebra 2 Regents exam. So I'm going to go ahead and I'm going to start with some exponent properties because these seem to always appear on the tests. So with exponents, you need to realize that whenever you have x to the power of a and you're raising it to the power of b, that's equal to x to the power of a times b. So a common Regents question could be, x squared raised to the 3a power is equal to what? And you'll just have to know that that's x to the power of 2 times 3a, which is 6a. Okay, another key rule here to remember is that whenever you're dividing exponents with the same base, okay, you're going to subtract their exponents. So if you have x to the power of a divided by x to the power of b, that's equal to x to the power of a minus b. Okay, so as long as they have the same base, right, you can just subtract their exponents like so. Moving on, if you ever multiply two exponents with the same base, x to the power of a times x to the power of b, that's equal to x to the power of a plus b. So for example, x to the power of 5 times x to the power of 7 is equal to x to the power of, well, 5 plus 7, which is 12. Okay. Now, we're going to get into more complicated examples of exponents. This is probably the thing that tricks students the most, okay? And that's going to be when you have a fraction as your exponent. So x to the power of 3 over 2. What's that equal to? Well, that's going to equal to the cube root of x squared. How do I know that? I know that because whenever you have x to the power of a fraction, let's say a over b, the numerator will just be the regular exponent, right? X to the power of a over 1 is just equal to x to the power of a. So the numerator is just going to be an exponent, but the denominator is going to be the degree of this radical, okay? So in this case, my denominator, and I realize that I wrote this wrong, guys, I'm sorry. This is x to the power of 3, the square root of x to the power of 3, okay? So the denominator is the degree of the radical, and then finally, the a, or the numerator, is going to be the value of the exponent over the x. So let's go over a problem like this. So if they ask you for an equivalent form of x to the power of 14 over 3, well, that's going to be what? Well, 14 is in my numerator. It's in my a slot, so I'm going to first of all just write 14 to the x to the power of 14, and then I'm going to take the cube root of it. Okay, why? Because I have 3 as a denominator, which means that it's going to go outside of the radical. Okay, remember that x to the power of 1/2 is equal to the square root of x, or x to the power of 1 and the square root. So technically there's supposed to be a 2 out here, but the square root, you don't need to write a 2 out here. You only need to write any number that's above 2, like when you're finding a cube root, or if there was a 4 here, or a 5, or a 6, so on and so forth. So whenever you see x to the power of 1/2, don't write 2 radical x to the power of 1, just write the square root of x, okay, or radical x. All right, talking about radicals, we're going to go ahead and talk about some radical rules that you guys need to memorize for this exam. So specifically, whenever you have x or radical x plus radical x, whenever you're adding two radicals with the same base or the same number inside of them, you just write how many there are outside of the radical. So in this case, I'm doing radical x plus radical x. So you're technically adding whatever's on the outside of the radical, which is just 1 and 1. So this is equal to 2 times radical x, because 1 times radical x plus 1 times radical x is equal to 2 times radical x. Same thing if I had 3 rad x plus 4 rad x, that could equal to 7 rad x. Okay? Pretty simple like that. But so let's go ahead and let's combine some of the rules that we know. If, for example, I have the cube root of x to the power of 5 times the cube root of x to the power of 6, what's that going to equal to? Well, look back at our exponent rules here. We know that we can rewrite both of these as x to the power of 5 over 3 times x to the power of 6 over 3. Remember that when you multiply two exponents with the same base, you're just adding them. So this is equal to x to the power of 5 over 3 plus 6 over 3, which is equal to x to the power of, well, 5 plus 6 is 11 over 3. That's the correct answer here. Or x to the power of 11, or the cube root of x to the power of 11 in that case. Okay, so that's how you would work out a problem like that. One last rule that I want to touch up on with radicals here, which is probably one of the most important rules with radicals, is when you multiply two radicals. So you know that when you multiply, for example, radical x by radical x, you're squaring it essentially. So that's going to turn into x. So when you multiply a radical by itself, you're getting rid of the radical. But if you have, for example, the square root of 79 times the square root of, let's say, 2, that's going to equal to the square root of 79 times 2. Okay, so that's pretty important to know. whenever you have multiplication underneath the radical, you can just write them underneath the same radical and then multiply them out underneath there. And that comes really handy when you're dealing with I, which is going to be kind of the first real algebra 2 topic that we're going to cover in this video. So I is an imaginary number, okay? It's what we use as a placeholder when our math doesn't really add up or doesn't really make sense, okay? And I'll give you an example of when that happens. So I is equal to the square root of -1, okay? And we use it as a placeholder to make math make sense. So for example, if you have a square root of a negative number, like the square root of -79, that doesn't exist, right? You can't have the square root of a negative number. So to rationalize this, or to make this kind of legal in terms of math, we write it as radical 79 times I. We just write I on the outside because I is, well, the square root of -1, and the square root of 79 times the square root of -1 is equal to the square root of -79. But writing this as I times rad 79 is perfectly legal in this case. So a lot of the times the Regents will ask you to deal with I, and specifically, simplifying terms that have I in it. So for example, a question could ask you to simplify 5x plus 3i times 3x plus 4i. And you'll just treat these like a normal algebra function, right, or algebra problem. So you'll multiply this term by this term. You'll get 15x squared plus 20xi, okay, plus 9xi plus 12i squared. Now, generally, when you have I on its own like this, you leave it alone, right? So let's combine like terms here. 15x squared is just on its own. Then you add that 20 plus 9 is 29xi. And because this I is alone, it's not being squared or cubed or raised to the power of 4, so we leave it alone. And then we're adding it to 12i squared. Whenever you have I squared, think about it. If I is equal to the square root of -1, if you square the square root of -1, that's just equal to -1. So this is equal to 12 times -1, which is -12. So when you simplify this, this is equal to 15x squared plus 29xi minus 12. That's all you need to really know when you're dealing with I here, okay? Aside from this, the only place where you'll really use I is when you're using the quadratic formula, which is again a major topic on this exam. So the quadratic formula is something you use to find the roots of a function, okay? So the quadratic formula is given to you as -b plus minus the square root of b squared minus 4ac over 2a. So if they ever ask you to find the roots of, for example, a problem like 4x squared minus 20 x plus 59, and you find yourself in a position where you can't FOIL this, right? You can't find two numbers that multiply into 59 but add into -20, or you can't find two numbers that multiply into 59 times 4 and add up into -20. In that case, you'll revert to the quadratic formula right here. So when you want to plug in terms into this quadratic formula, the first term will always be your a, the second term will be your b, including the sign, and the third term will always be your c. So if I plug these values into this function, I get -20, which is actually just equal to +20. Okay, so this is actually just +20 plus minus the square root of -20 squared, which is 400, minus, and then if you ever get confused about the math when you do 4ac, I just put a minus, and then in parentheses I put my a, which is 4, times 4, which is just always there, times c, which is +59, okay? And then this is all over 2a, so 2 times a is 8. Now just evaluate whatever's in underneath this radical. So you know that 4 times 4 times 59, I believe, yeah, 4 times 4 times 59 is equal to 994, and 400 minus 994 is equal to 594, okay? So the issue here that we're left with is our answer is written improperly. We have 20 plus minus the square root of -459 divided by 8. And remember that you cannot have a negative square root. So what you'll have to do here is you'll have to just write it as radical 459i, because you're taking out that negative to make this a regular or acceptable answer, and then you're dividing everything by 8. And usually the Regents wants you to simplify your answer, so you can divide this side by 4 to get 5, and this side by 4 to get 2. So you'll have 5 plus minus radical 495 divided by 2, okay? So another key tip that you kind of need to know for the Algebra 2 Regents is how to simplify radicals. So for example, if instead of the square root of -459, as my answer, let's say I got 20 plus minus radical, let's think of a good one here. Let's say 80 divided by 8. If I put this as an answer and they asked me for an answer in simplest terms, this would be marked as incorrect because technically you can further simplify this down. And I'm not just talking about dividing the 20 by 4 and the 8 by 4 and getting 5 plus minus radical 80 divided by 2, right? That would be incorrect here. Why would that be incorrect? Because you're not simplifying the radical 80 like you need to. So whenever you have the square root of a number or a square root of an 80, always check if you can multiply this into a perfect square. So if I look at the square root of 80, I know that 80 itself is equal to what? That's just 80 times 1, that's 4 times 20, that's 16 times 5. So if I look at the factors here, what I end up seeing, oh, this is also 8 times 10. But what I end up seeing here is I have two perfect squares as my factors. And whenever you have two perfect squares, you just want to choose the bigger one, okay? And I'll show you why later. So this radical 80 is the same thing as saying radical 16 times radical 5. Okay, we know that radical 16, or the square root of 16, because 16 is a perfect square, is just 4. So this is actually equal to the 4 root 5. And then you just slap on the plus minus 20 at the start of it and divide it by 8. And if you divide everything by 4, you're left with 5 plus minus radical 5 over 2, which in this case will be marked as the correct answer because it's fully simplified. Okay, now why did I choose the biggest square root? Well, I chose the biggest perfect square because if I, said, oh, well, 80 is divided by 4 and 4 is the perfect square, then the square root of 4, I'd be left with the square root of 4 times the square root of 20, and that would have gotten me 2 radical 20. But remember that radical 20 is equal to 4 times 5, right? So the square root of 4 times the square root of 5, so that's the square root of 4 times the square root of 5. Square root of 4 is 2, so I'm multiplying 2 by the square root of 5, but there's already a 2 on the outside, so I'll just have to multiply it again, and I still get 4 radical 5. I just had to do an extra step. So that's why you always have to choose the biggest radical, okay? So we went over the quadratic formula. This is how you find the roots of the problem, okay? And essentially what the roots will tell you are the zeros, right? So the roots are the x values that make the entire function equal to 0. In other words, if you had a function that looks something like this, right, the roots would be the points at which the graph crosses over the x-axis. If this is the x and this is the y, then this would be a root, this would be a root, this would be a root, this would be a root. So what this formula tells you is that x has to equal to some number, right? This plus minus that, okay? And that's going to tell you values that if you plug those back into the function will give you something that tells you 0, right? Or that gives you 0. So that's a part of a bigger term or a bigger topic called factoring. So let me just quickly go over some of the factoring that you'll see on this Regents exam. So in terms of factoring, what you'll need to know is how to factor out trinomials. So something new about factoring on the Regents is you won't just be asked to factor out things that are to the power of 2 anymore. You won't be asked to factor out x squared plus 6x plus 8, for example. If you don't know how to do this, let's quickly go over it. X squared plus 6x plus 8, you're looking for two numbers that multiply into 8, but that add to 6. So 4 times 2 is equal to positive 8, and 4 plus 2 is equal to positive 6. So we can do x squared plus 4x plus 2x plus 8, and then we could just see whatever terms they have in common. So the reason why we did this division or this split is so that we have an equal left and right side that each have two terms. So from this two-term left side and this two-term right side, I can just take out certain terms. So what do x squared or x times x and 4x or 4 times x have in common? They have x in common, so I can take that out. And I'm left with x plus 4. Here I can take out 2 and I'm left with x plus 4. And a factored out version is 2 plus x times x plus 4. And again, the factors, if you set them equal to 0, will give you x values that make the entire function equal to 0. Because if you make any one of these parentheses equal to 0, the whole thing comes crumbling with it. So to find the zeros, just do 2 plus x is equal to 0, so set both of the parentheses equal to 0. Okay, so let's look at something more complicated that might pop up on your Regents exam, and that's knowing what x cubed minus 1 is equal to. I just like to remember it as x minus 1 times x squared plus x plus 1. Okay, so this form is essential for you to understand on the day of the test. And just having this memorized makes the math a lot easier to deal with, okay? So there'll for sure be some problems that have x cubed minus 1, and you have to give an equivalent expression to it, so that's how you would do that, okay? Then you also need to know that x cubed plus 1 is just equal to x plus 1 times x squared minus x plus 1, okay? So those are the two forms for x cubed that you need to know. You also need to know in terms of factoring that a squared minus b squared is equal to a plus b times a minus b. So for example, if you were dealing with a problem that look something like this. Factor out completely x cubed plus 9x. So you might be completely lost here, but if you really think about it, I can take out x from both of these terms, right? What does x times x times x and 9 times x have in common? Well, they have x in common. So if I take that out, I'm left with x squared plus 9, right? So that's one way that you can start factoring things out, right? Just think about, if you have an x cubed, don't get scared, right? Just write out the components of these variables, like so, and then just don't be afraid to take something out, okay? Now, what if I was dealing with the problem x cubed minus 9x, okay? So if I were to go ahead and factor out x and write x times x squared minus 9, I wouldn't actually get full credit here. And the reason being is because this is a difference of perfect squares. This is a squared minus b squared. So I can rewrite this as, well, you know that x squared is equal to x to the power of 2, and you know that 9 is equal to 3 to the power of 2. So I can rewrite this as, well, x plus 3 times x minus 3 times x, okay? And if they wanted me to solve for the zeros, then I would just set each one of these terms equal to 0. And yes, that includes the x. So I would do x is equal to 0, x plus 3 is equal to 0, and then x minus 3 is equal to 0, okay? So that's how you find, or that's how you factor even the hardest or the trickiest problems out, okay? And what else you can do is you can always make sure that you have 4 terms when you're factoring something out. So for example, if you had a problem that looks something like this, x cubed plus 2x squared plus 4x plus 2, right? What you can do here is you can just split, because it's already in 4 terms. 4 terms is your magic number. You always want to be dealing with 4 terms when you want to factor something out, because that's just the most optimal way of factoring, because that gives you a left and a right side that are both equal to one another. And what you can do here is you could just factor out x squared from this side, and you're left with x plus 2. You can factor out 2 from this side, or yeah, you can factor out 2 from this side, and you'll be left with 2x plus 1, okay? And if I thought about this problem harder, this would be a better example. If you just had x cubed plus x squared plus 4x plus 2, if you factor out x squared from here, you're left with x plus 1, and here you have 2 times 2x plus 1, okay? So again, sorry guys, I'm making these up on the spot, so it's harder to think of math than it is to solve it for me. So either way, if you factor this out, you factor out x squared here, you're left with 2x plus 1. Here you're left with 2 times 2x plus 1. Then you can factor or combine these into one equation, 2x plus 1 here, and then x squared plus 2 over here. Okay, so that's how you would factor out something that's more complicated like this. Just divide it in the left and the right sides. And the final thing I'm going to talk about factoring here is completing the square. This still appears on the Regents, believe it or not, right, for Algebra 2. Whenever you want to complete the square, you're going to be given something that can't be factorable. So for example, x squared minus 20x plus 3, for example, right? And if they want you to complete the square, what you'll have to do is you'll have to set it equal to 0. So if they have the function, f of x is equal to x squared minus 20x plus 3, set it equal to 0, and then subtract the regular number away from it. And now you're left with x squared minus 20x is equal to negative 3. Then what you want to do is you want to take negative b over 2, and then you want to square it. So remember, your a is your first term, your b is your second term, including the sign, and your c is your third term, right? So in this case, you're taking negative 20 over 2, and you're squaring it. So negative 20 divided by 2 is negative 10, and negative 10 squared is 100. So you're going to add 100 to both sides. And what you're going to find is x squared minus 20x plus 100 has to equal to 97. Now what you have to do here is you have to just factor out this side. And you'll find out that this side factors out into x minus 10 squared. Okay? So in other words, your x will always factor into whatever your negative b over 2 is equal to. Okay? So in this case, negative b over 2 is equal to negative 10, so you're left with x minus 10 squared, or you could have just done the factoring. It's not that hard. And now it's equal to 97. Okay? That's how you would complete the square. And if they wanted you to solve for x, from here all you would have to do is just take the square root of both sides, okay? And this segues into what I want to talk about when we talk about extraneous solutions. So sometimes when you do math, you'll find a solution that doesn't work. So for example, if I were to take the square root of both sides, right, I would get that x minus 10 is equal to the square root of 97, right? And because I'm taking the square root of both sides, I'm actually going to set this to plus and minus the square root of 97. Okay? Why? Because sometimes when you square something, right? For example, 3 squared is the same thing as saying negative 3 squared. So that's why you have to add the plus and minus 97 outside here. And whenever you solve for a value of x that doesn't make the left side equal to the right side, that's something that we call an extraneous solution and something that we reject. Now, for those of you that really don't like factoring, a quick workaround for the multiple choice section for factoring could be to just to graph the original function. So for example, if this question asks you to, graph this function right here, to factor out 2x cubed plus x squared plus 4x plus 2, you can go ahead and plot that into your calculator. So 2x cubed plus x squared plus 4x plus 2, right? And then you can factor out the answer choices. Sorry, you can graph the answer choices. So in this case, this is what I got as my answer. So if I graph it out, x squared plus 2 times 2x plus 1, I see that I'm left with two graphs, technically, because I graphed two lines, but the lines literally graph or overlap one another. So because the lines overlap one another, what you're left with is two equations that are equal to one another. If I press second and graph, you can see that they have these same exact answers, which means that they're equivalent ways of expressing both fractions or both functions, and that's how you know you're correct. So now let's talk about, solution sets, okay? So whenever you have two lines that intersect, the point of intersection is going to be what we call a solution. And you can find the solution for example, let's say f of x is equal to, 3x squared plus 1, or like g of x is equal to, 2x squared minus 5. If you want to find the point of intersection, you can just graph it. So you can go into your calculator, graph these two equations, press graph, then you can go into second trace, go all the way down to intersect, and then use the intersection function to find the point of intersection, which is going to be the solution. Now, when you evaluate the solution, it's always just going to be equal to x. So the solution to this function is just that value of x that makes both of these equal to each other. Now, if this is a short response section, and you cannot, just plug it into your calculator and just select a random answer, what you can do is you could just set 3x squared plus 1 equal to 2x squared minus 5, and then just solve for x. How do you do that? Well, you just combine like terms, so you can subtract 2x squared from both sides. You get x squared plus 1 is equal to negative 5. Move the negative 1 over here, you have x squared is equal to negative 6, and then x is going to equal to, or actually, you're going to be left with x is equal to the square root of negative 6, which means that these two lines actually do not intersect, meaning that there's no solutions. Why? Because you can never have the square root of a negative number, so there's no solutions to this. And essentially, when a system of equations have no solutions, that means that they actually don't intersect. So if I were to graph these two out, 3x squared plus 1, and what was the other one? 2x squared minus 5. I can see that these two lines actually never touch each other, okay? They go around one another, but since they never touch or they never intersect, what we're dealing with here is something that has no solution, okay? So let's go over dividing polynomials now. And that's probably going to be like the last realistic topic of math that I have to go over with you guys. Everything else is kind of going to be either graphing or conceptual or probability. So like the hard part of the video, in my opinion, is pretty much over for you guys to understand, right? I think that dividing is probably going to be some of the hardest things that you have to do on this Regents exam, but aside from that, everything else is probably going to be easy, okay? So we're just going to talk about graphs next. So when you divide polynomials, right, just remember that, let's say you have a function that's like 3x squared plus 3x plus 2 divided by x plus 1. Okay, remember that the numerator and the numerator is whatever's in the top, the denominator is in the bottom. So when you go ahead and divide this, set up your division bar like this, put the numerator on the inside and put the denominator on the outside. So if I wanted to divide these two, I would put 3x squared plus 3x plus 2 in the inside and x plus 1 on the outside. And then I ask myself, how many times does this x go into 3x squared? Okay, so if you're confused about this, just write out what 3x squared is. Well, 3x squared is just 3 times x, and x is just x times 1. So what do they have in common? They have x in common, so you can circle it and cross it out. And what are you left with? You're left with 3 times x. So x goes into 3x squared 3x times. And that should make sense because if you multiply 3 times x, you get 3x squared. So that's how you figure out the first term. Then you just multiply them. So x times 3x is equal to 3x squared. That's how I know that I figured it out correctly. And then what do you do with the second number? Well, because we're dividing by positive 1, all you have to do is just multiply positive 1 by the number that you chose right here. So now positive 1 times 3x is positive 3x, okay? So you subtract these two. Now, a key note when you're subtracting in this way, you write the top number down first. So for example, you write down 3x squared first, and then you write down the minus sign. Then you write down the second number, 3x squared. This is going to equal to 0. This is going to equal to 0. And then you can ask yourselves, well, how many times does x plus 1 go into 0? And that's going to be, well, 0 times, because x times 0 is 0. So we can just add 0 to the side. And everything times 0 is 0, so you're going to be left with nothing. And then you can drop down your 2 right here, and you're going to ask yourself, how many times does x go into 2? And then your answer is, well, it's not 0 times, there's just no number that you can multiply by x to turn it into 2. So as a result, this 2 is what we call a remainder. So if this was a normal division, right, and I didn't make it difficult or complicated, you would just get like, I don't know, like 3x plus 3 as your answer, and then you would just be able to move on with your life, right? Unfortunately, I had to make it complicated. So the quotient here, right, if you wanted to write the answer, you would have to do the following. You'd have to write your quotient, which is whatever is on top of here, plus your remainder divided by the divisor, or the denominator that's on the outside. So the answer here would be 3x plus 2 over x plus 1. And if you're ever confused about division, again, you can use this trick in your calculator. You can go into y equals and you can graph both functions. So here we can graph 3x squared plus 3x plus 2 divided by x plus 1, and then we can graph our second function here, which is 3x plus 2 over x plus 1. And if we hit graph, we see here how the two lines go over one another, they overlap. If I hit graph, they have the same values, which means that this is the correct answer, and I did my math correctly. Good for me. So essentially, when you do long division like this, you're figuring out whether what you're dividing is a factor or not. So because x plus 1 did not divide evenly into this function, you know that it's not a factor. But, for example, let's say that if you divided by x minus 1, right? If you divided by x minus 1 and you got an answer of, 3x plus 3. If you divide something and it has no remainder, that means that it's a factor. So that means that x minus 1 is a factor. So if I were to factor this one out, x minus 1 would be one of the values in the parentheses, which means that when you plug in 1, the entire function is equal to 0. The Regents asked a question like that during its last exam. They said that like x minus 5 was a factor to a polynomial, and you know that if x minus 5 is a factor, that means that when x minus 5 is equal to 0, that tells you that whatever that x value that makes x minus 5 equal to 0 makes the whole function equal to 0. So the answer was that, f of 5 is equal to 0, right? So how do you check if something is a factor? You can divide, and then what do you do with the factor? Well, you set it equal to 0 to find one of the zeros of the function, okay? What else can I go over in terms of just pure math here for you guys? Scrolling through my list of topics right now. There's system of equations on this exam, obviously, but I don't think that's a big trouble for you guys. The biggest piece of trouble, or the biggest trouble that I think you'll face, is when you have 3 system of equations. For example, you can have x plus y plus z, and then 2x plus 4y plus 6z, and then negative x plus 3y minus 5z is equal to like 11. This is equal to 2, and this is equal to 1. So I don't really have any advice in terms of how to solve these effectively. All you kind of have to do is just trial and error. My advice is to always go for the simplest one. For example, x plus y plus z. You can easily solve this for x and then plug that value of x into this bottom equation and then just solve from there, which is pretty easy. But if you're really bad at that, what you can do is you can go into your calculator and you can click second x minus 1, right, or the inverse of x, to get into a matrix. And then you can go and press edit, okay? And you'll be in a place that says, or that's called matrix A. So what you can do here is you can copy your data right here into that matrix. So this is 4 by 3. So this is 3 and 4, right? So the 3 is the number of columns. So in this case, I have 1, 2, 3 columns, and I have 4 rows. And then all you have to do is, number 1, you have to make sure that all of your x's are in the first row, or the first column, all of your y's are in the second column, and all of your z's are in the third column, okay? Then you just have to put in the coefficients. So here, x is equal to 1x, okay? So we'll put 1 here. Then we know that 1y is equal to 1 times y, so there's a 1 in its coefficient. Over here, we know that z is equal to 1 times z, so there's a 1 in its coefficient, and we know that it's equal to 1. Okay, now over here we know that 2 is the coefficient of x, here we know that 4 is the coefficient of y, and here we know that 6 is the coefficient and it's equal to 2. Okay, and finally here we have negative x, meaning that the coefficient is negative 1. Over here we have 3y, here we have negative 5z, and then it's equal to negative 11. Oh, it's not just positive 11, okay? So now that we have our answer in our matrix, we can press second mode to quit. We can go back into the matrix, okay? And we can go to math. When you go to math, scroll all the way down to REF, press enter, and then go back into matrix. Sorry, go back into matrix and then press enter to enter the matrix that you just found. And what it'll do is it'll tell you the values of each one of these variables when the coefficient in front of the other variables is equal to 0. So for example here, it's saying that if you plugged in 1 for x, or 1 in the x slot, 0 in the y slot, and 0 in the z slot, it would equal to 1. So essentially, this is saying that 1x is equal to 0, or that x is equal to 0. This row right here is saying that 1y, or 1 times y, when everything else is multiplied by 0, is equal to 2. So you know that y is equal to 2. Over here, you have 1 in where you would have your z. So it's saying that 1z is equal to negative 1, or z is equal to negative 1. And that's just a quick workaround to doing otherwise 5 or 3 minutes worth of math. So I think you should all memorize how to do this, right? The matrix for sure saves a lot of time on this exam, and I doubt that they'll ask a 3 system of equations question on the short response. But if they do, you could use this to check your answer, at least to get partial credit if you're completely lost. But just remember how to do the math. Start with the most simple equation, rewrite it in terms of one variable. So you can rewrite this in terms of x is equal to 1 minus y minus z, and then you can plug that into this number right here. So you know that negative x, or negative 1 minus y minus z, is minus 5y, plus 3y minus 5z is equal to negative 11. Then you can say that negative 1 plus y plus z plus 3y minus 5z is equal to negative 11. So then you can say that 1 plus 4y minus 5z is equal to negative 11. Subtract 1, you have 4y minus 5z is equal to negative 12. Add 5z to both sides, you get 4y is equal to negative 12 plus 5z divided by 4, and that's how you solve for y. And now that you've solved for y and for x, you can plug both of those into a brand new function, and then you can solve for z, and then just plug in z and solve for every other equation. I personally think that this is just a lot faster and probably a lot easier for you guys, and I think that's pretty much the last part of real math you need to know for this exam. Everything else is just definitions. Let's go over them. So functions is a relationship that always have to pass the vertical line test. So if you ever have a function on a page and you cannot draw a vertical line through it without passing through 2 points, that's not a function. So for example, a circle isn't a function because it does not pass the vertical line test. If you draw a vertical line which is straight going up and down and it passes through more than 1 point, you know that it is not a function. Okay, so that's the function test. The other way that you can do this is by seeing whether or not every x input has one y output. So in other cases, if you're given a bunch of points, like for example 1, 1, or 2, 2, 3, 3, this is a function because every single x has one y output. Okay, every x input has one y output. But let's say that you had 1, 1, 1, 3, 1, 4. Would this be a function? No, remember that this is x, y. This is x, y. So in this case, you have one x input of literally 1 that has multiple y outputs. That's false. Only one x input can have only one y output. Okay, so there should be no repeats in x values, right? X can only be equal to one number. Now, I'll ask you this question. What if I had the point 1, 1, 2, 2, and 3, 2? Would that still be a function? Yes, it would still be a function. Why? Because you're not repeating x values, okay? Every single x value has a unique output, okay? 1 has a unique output of 1. 2 has a unique output of 2. 3 has a unique output of 8, okay? Now, what if we had 3, 2? Would this still be a function? Yes, this will still be a function, right? Because 1 has a unique output of 1. 2 has a unique output of 2. 3 has a unique output of 2. Even though the x values have the same output, they still have one output. They still map onto one output, which is what makes them a function. Okay, so talk about more about functions, right? The domain of a function is all x values, so that's the domain of a function. So for example, the domain of this function is going to be from negative infinity all the way up to positive infinity, okay? Why? Because whenever you see an arrow, you know it's going to infinity in that direction. So this isn't this is not a vertical arrow going up, so you know that the domain is just going to go on forever because you have two vertical arrows. The range is the same thing as the domain, just for y values. So if I look at this graph, I'll see that its vertex or its minimum is at 3. So the range has to be from 3 all the way up to infinity because it's just going up from there. And you might notice that I use a square bracket instead of parentheses. Whenever a point is not included in the domain or range, well, you use a parentheses, and whenever a point is included or is found in the range, you use a bracket. So in this case, well, infinity is like something you can't reach technically, so technically infinity is not a part of this graph, which is why you always put it in parentheses. But if it passes through a point, you'll put it in brackets just because, well, it passes through that point and it's a part of it. Okay, so let's talk more about graphs. Let's talk about average rate of change. Average rate of change is just the slope between 2 points. In other words, it's equal to f of b minus f of a over b minus a. So for example, if you wanted to find the average rate of change over the interval 0 to 4 for this function, you would take the y value when the function is at 0, so f of 0, minus f of 4, which is the y value when the function is at the end of the interval, divided by the start of the interval minus the end of the interval, okay? Or you could have done f of 4 minus f of 0, or the y value at the end minus the y value at the start, over 4 minus 0. Both of these terms give you the correct average rate of change. Just remember that on the Regents, your average rate of change, oftentimes they ask you to interpret it, meaning that if like your y-axis has units, like, I don't know, let's say that this is kilometers and this is hours. So if you're subtracting kilometers, your units is still going to be kilometers, and if you're subtracting hours, your units are still going to be hours. So if they ask you to explain this, what this meant, you could say that, oh yeah, the average rate of change, or his average speed, was for the entire trip, or for the interval 0 to 4 hours, was 5 or 7 kilometers per hour, or whatever number you'd get from doing that calculation. Okay, right, so what else can we go over here? Let's go over rationalizing denominators. I lied, guys. There's one more math thing that you guys needed to do. So whenever you need to rationalize a denominator, essentially all you have to do is just multiply it by its conjugate. So for example, if I had 2 over radical 2, to rationalize this, I just multiply the top and bottom by whatever is irrational, which is radical 2. And I'd be left with 2 radical 2 over 2, or just radical 2, right? Yeah, that makes sense. Okay. But if I had something like 2 over radical 2 plus 1, then I would have to multiply by, again, the conjugate, which is the same thing. What makes this irrational? It's not just the radical 2, it's the radical 2 plus 1, because you know radical 2 plus 1 is irrational. Okay, so you'll multiply this by radical 2 minus 1. Be careful. Whenever you multiply by a conjugate that has more than one numbers, flip the signs. Okay? So flip the signs, and you'll be left with 2 radical 2 minus 2 over radical 2 plus 1 times radical 2 minus 1, which you can simplify on your own. Okay, so just remember that you flip the signs when you have more than 2 terms. Okay, so let's just see what we've gone over so far. So we've gone over dividing polynomials. We know what rational and irrational numbers are. If you don't know, an irrational number is something that is a number that has a non-terminating, non-repeating decimal. So for example, pi, if you plug it into your calculator, pi, you know that it's irrational because it doesn't stop, and you also know that it's irrational because it doesn't follow a pattern in its numbers, right? So if I had like radical 3, guess what? That's also irrational because it doesn't stop and it doesn't follow a pattern with its numbers. But if I have, for example, 1 divided by 3, this is rational because even though its decimal does not stop, it keeps repeating numbers, which is why it's rational. It also can be expressed as a fraction with a denominator other than 1. So 1 divided by 3 can be represented as a fraction 1/3, okay, which is how we know it's rational. And you may be asking me, well, how come radical 3 isn't rational? Isn't radical 3 equal to radical 3 over 1? Well, the trick with the fraction here is that it has to be equal to a fraction with a denominator that's not only equal to 1. Okay, so then we also talked about the remainder theorem, which just says that whenever you have a remainder, you have to list it, right, as the quotient plus the remainder over the divisor. Okay, the factor theorem. We talked about when something has no remainder, then it must be a factor for that, okay? We talked about how to divide, what to do when we have a remainder left, okay? We talked about how to factor. We talked about the quadratic formula. We talked about complex factoring. We talked about perfect cubes, right? Or what to do when you have x cubed minus 1 cubed or whatever, like something like that. We talked about how to rationalize expressions, okay? Rationalize denominators. We talked about properties of exponents and radicals. We talked about rationalizing denominators, about complex numbers like I. So we talked about functions as well. So I think we're making good pace, okay? So if you had questions on any one of those topics that I just told you about, go back in the video and rewind them, right? I want you guys to be aware and ready for this exam, right? So a couple more things I want to touch up on before I finish off this video, okay? I want to talk about which of the following. I just want to quickly talk about adding and subtracting fractions with exponents in the denominator. I know I said no more math, but I keep lying to you guys. I'm sorry. So if I had something like 3 over x minus 2 over x squared, if I wanted to simplify this, I can combine like terms. It just doesn't sound like it's clear. I can rewrite this by setting the denominators equal to one another. So how do I make x equal to x squared? Well, I can just square this x, okay? So how do I do that? Well, I can just multiply the top and the bottom by x, okay? Remember that you can't just square this whole thing, because whenever you're setting the lowest common denominator, you're just multiplying by the top and the bottom by a single number. If I squared this entire fraction, I'd be multiplying by 3 over x, which is not the same as finding the lowest common denominator. So this would be 3x minus 2 over x squared. That's what it would be simplified to. Right? Let's say I had 3 over x minus 2 over 2x. How would I simplify this? Well, I can just find the lowest common denominator between x and 2x. That'd just be 2x. So I have 6 over 2x minus 2 over 2x. Whenever you have the same denominator, you can just combine them into one denominator, and you could combine whatever's happening up top into the numerator. So 6 minus 2 over x, which is 4 over 2x, which is just going to be, what is that? 4 over 2x, which is going to be 2 over x. Okay, that's what that simplifies into essentially. Okay, so that's how you deal with fractions that have, again, variables in the bottom of it. If you ever have a situation where you have, like 3 over x is equal to x squared plus 3, and you need to know how to solve this, what you can do here is you can just cross multiply. So multiply the top by the bottom and the bottom by the top and set it equal to each other. So 3 times 3 is 9, and 9 is equal to x cubed. From there you can just solve for x, okay? What else can we go over, guys, before we talk about graphing? What else can we go over? We can also go over sequences, right? And series, okay? So let's talk about series, right? So we have two types of series, right? We have arithmetic sequences, I call them series, but they're really sequences. So we have arithmetic sequences and we have geometric sequences. An arithmetic sequence is going to deal with adding or subtracting a value to get to the next term. So for example, an arithmetic sequence could be 1 plus 2 plus 3 plus 4 plus 5, okay? The common difference is what number you're adding to the previous term to get to the next one. So in this case, that term is 1, okay? And essentially you have a formula. A of n is equal to a of 1 plus n minus 1 times d. So d is the common difference. So in this case, that would be 1 because you're adding 1, positive 1. A of 1 is your first term, and a of n stands for any term, okay? So a is the amount and n is a certain position. So each number here has a certain position associated with it. This 1 is in the, you guessed it, first position, so we know that a of 1 is equal to 1. The amount, when the position is 1, is 1. And you're adding that to n, which is the position of a future term, minus 1 times the common difference, which is just how much you're adding to or subtracting to get to the next term, which is just going to be 1. So the explicit formula here is a of n is equal to 1 plus n minus 1, okay? The explicit formula, again, the general formula, how to get any term, right? The way I like to remember what a of n is an sounds like any, kind of, looks like any, all right? Let's talk about a recursive formula. A recursive formula is always determined by the previous term. So to write a recursive formula, it's pretty simple. You just state your first term, or a of 1, and then you're going to say that a of n, or the next term, is equal to a of n minus 1 plus the common difference, okay? Pretty easy, guys. All right. And if you ever want to find the common difference, just take a2 minus a1. So take the second term in the sequence and subtract it from the first term in the sequence. And using this formula, you can find any term here. Or if you're given like the fifth term and the first term, you can use this to solve for the common difference just by plugging in values, okay? And remember that whenever you want to solve for like the fifth position, a number in the fifth position, the n is the position. So you can replace this with 5, and solve like that, okay? So geometric sequences are going to be similar, just in the sense that they multiply and divide to get to the next term. So if I had like 2, 4, 8, 16, 32, 64, this would be a geometric sequence where the common difference is, where the common ratio, remember now instead of difference it's ratio, is 2, right? The common ratio is 2 because if I do a of 2 over a of 1, or the second term divided by the first term, well, guess what? That's going to give me 2. And the formula here is a of n, or any term, is equal to a of 1 times the ratio to the power of n minus 1, okay? And this is all on your reference table, by the way. You're just trying to explain the formula. And if you want a recursive formula, like always, it's a of 1, you have to state it first, and then you have to state the rule. So a of n is equal to a of n minus 1 times r. Pretty simple, guys, okay? So recursive formulas are going to follow the same format for either one. One of them is multiplying by r, the other one is adding or subtracting, okay? And you're adding or subtracting to something that always has a of n minus 1, okay? The general formula is something that could confuse people, but if you just remember what n is, what a is, you'll be fine for this exam, okay? And all you need to remember here is that every single term is always going to follow the same rule, and if a certain term does not follow the common difference or the pattern that we've established by dividing the second term by the first term or subtracting the first term from the subtracting the second term from the first term, guess what? It's not a sequence, okay? So I think we can go ahead and move on to graphing finally, okay? So we can go ahead graph. So the biggest graph that we're probably going to talk about on the Regents is the parabola. Okay, and there's kind of like an important part of this parabola. The equation for a parabola is like f of x is equal to 1 over 4p times x minus h plus k, where h comma k is going to be the center or the vertex, okay? So the vertex is either the tip or the maximum of the graph or the minimum of the graph, like so or like so. So for example, if I had a graph that looks something like this and the vertex had a coordinate of 2, 3, well, guess what? My h would be 2 and my k would be 3 because those are the values I need to plug in to get that specific point, okay? Now, what about p? Well, p has to deal with something called a directrix and a focus. So whenever you draw a parabola, it's actually situated between 2 points. The first point is called the focus, okay? And the second point is called the directrix. The directrix is a flat line and the focus is just a point. The vertex is always going to lie between the focus and between the directrix, okay? And the line itself, the parabola itself, can never actually touch the directrix, okay? And it also can't cross through the focus. So if the directrix is on the bottom and the focus is on the top, your graph opens upwards and must be positive, okay? Now, if the directrix is on the top and the focus is on the bottom, because your graph cannot intersect here or here, right? It cannot cross the directrix, what's going to happen is your graph is going to be opening up downwards like so, and it's going to have a negative number in front of it. Now, let's say that this focus was located at the point 2, 5. Notice how, again, they have the same x values. So the x value of your parabola, right, or of your vertex is going to have the same x value as your focus. And let's say that the directrix was y equals 0. Remember that whenever you have y equals, it's a flat line. So the distance between the directrix and the vertex is the same as the distance between the vertex and the focus. So in this case, the distance from the directrix to the vertex is 2, and the distance from the vertex to the directrix is also 2, okay? And I noticed my mistake here. Let's say that the directrix is equal to y equals 1, okay? So the distance between 1 and 3 is 2, and the distance between 3 and 5 is also 2. So that distance is going to be your p, so p is equal to 2. So the full formula for this is f of x is equal to positive 1 over 8 times x minus 2 plus 3. Okay, so that's how you operate with parabolas in this case. Okay, that's all you need to know about constructing a parabola, the vertex or the minimum slash maximum of a parabola, and the directrix and focus. Okay, so let's talk about graphical transformations. If I had the equation, f of x, right, I can do multiple things with this function. Right, what I can do is I can, shift it up and down. Okay, if I want to shift f of x up and down, if I want to have a graph and make it shift from here all the way up to here, what I can do is I can add a number outside of the parentheses of x. Okay, if I want to shift it downwards, I can subtract a number outside of these parentheses. Okay, now let's say I wanted to shift this graph to the left or to the right. What I can do then is I can just do f of x minus 3 to shift it to the right, and I can do f of x plus 3 to shift it to the left. Okay, remember that has to be inside the parentheses, and this is up and this is down. Okay, so for example, if f of x is equal to x squared, then doing x squared plus 3 is shifting it up, but doing x plus 3 squared, literally doing it to the x inside of a parentheses, meaning that you're exclusively adding to x, that would result in a shift 3 units to the left. Okay, and then finally you can dilate or kind of expand or widen how much a parabola opens up with. So if you have, 5 times f of x, that's going to be a very narrow parabola. And if you have 1/4 f of x, that's going to be a very wide parabola. So the smaller the number in front of the f of x, the wider the parabola, and the bigger the number in front of f of x or in front of x squared, that's going to be the more narrow that parabola is going to go down with. Okay? So finally, if you have a positive number in front of f of x and it's a parabola, then it's going to go open upwards like this, like a smiley face. So if you have positive x squared, it's going to make a smiley face. If you have negative x squared, it's going to go down like this and make a frowny face. Okay, that's how I like to remember it. I understand it's a little bit silly, you guys are high schoolers, but it's a fun way to remember it at least. I don't know. So guess what? That's not the end of this video. We still have a lot more to cover. Okay, so let's look at some more important points when you graph. You know that when you have a parabola, right, and it never touches the x-axis, that means you have imaginary solutions, right? Your solutions do not exist, because remember, the solutions to a graph is either when there's two graphs and they intersect, or when the graph itself crosses over the x-axis. And the points at which the graph crosses over the x-axis are going to be the zeros of the function. Okay, so that's all you need to know about parabolas. Let's talk about linear lines. So whatever makes a line linear is, well, just the fact that it has this constant slope. It's changing by the same amount every single time, right? So if you're ever given a table and it asks you to find whichever relationship is the linear one, well, you see whichever one changes by the same amount each time. So if you had the days that you worked and the money that you earned, on day 1 you earned 30, on day 2 you earned 60, on day 3 you earned 90, on day 4 you earned 120. This would be a linear equation or a linear situation because you're increasing by 30 every time. But if you had a relationship that looks something like this, the first day you got paid $2, the second day you got paid $4, the third day you got paid $8, and the fourth day you got paid $16, well, you're increasing by 2 here, then by 4, then by 8. So you're not increasing by the same amount every time, so this is exponential. Okay, so we know that y equals mx plus b is the linear equation slope, or the equation for a linear equation. I don't know, it sounds kind of redundant, but m is your slope, b is your y-intercept. Okay, so b is the height at which you'll cross or touch the y-axis, and m is going to be the slope. That's delta y over delta x, or your change in y over your change in x. So you'll do y2 minus y1 over x2 minus x1 to figure that out. Okay, so let's go ahead and let's talk about exponential growth and exponential decay problems now. Okay, so pretty simple stuff here, right? Exponential growth can be modeled by this function. You have a, or the amount, is equal to p, the initial, times 1 plus minus the rate to the power of time. Okay, so if this is a decay, you know that your rate is going to be negative because you're decreasing. So that's for decay. And then for growth, you have a is equal to p times 1 plus r to the power of t. Why is it plus r? Because, well, you're growing, so this is your growth, right? And then there's one final rule when you're talking about compounded interest that's compounded continuously. So interest that's compounded continuously follows the formula a is equal to p e r t. Okay, so a pert. P is again your initial amount. E is Euler's number, right? That's a specific function on your calculator that's equal to like 2.176. You can find it over here, e to the power of whatever. Okay, so you'll raise it to the power of your rate at which you're growing at and multiplied by time. So essentially, when you have compounded interest, you're earning interest on your investment every single second, every single microsecond, every single zeptosecond. Like, continuous means continuous, okay? Rather than if something is compounded quarterly, meaning that it's compounded 4 times a year, or if it's compounded daily, okay? This E is kind of like the speed limit of the universe in terms of growth, okay? So if a problem ever asks you to find the sum of one of these series, again, you could always find it in your reference table, but if they want you to find like the sum of the first 5 terms of this sequence right here, you can always use this formula. S of n is equal to n times a of 1 plus a of 2 over 2, right? Sorry, S of n, or the sum of all those numbers, which you define by plugging in how many numbers in the n slot, is equal to n times a of 1 plus a of n divided by 2. And for a geometric sequence, it's a of 1 times 1 minus r to the power of n divided by 1 minus r, okay? So I'm pretty sure that both of these are given to you on the reference table, but just in case they're not, go ahead and memorize them, right? If you have a question about a sum, pretty useful to know so you guys don't get tripped up. So the last thing we really need to talk about in terms of graphing is graphing waves, okay? And this might be complicated to some students, but I promise you that it's never that bad, okay? So a wave just has many different things you need to remember about it in its formula, okay? So the formula of a wave is always going to be like f of x is equal to a sine bx plus c, or it could be f of x is equal to a cosine bx plus c. So essentially this a is the amplitude, this b is the frequency, and this c is going to be the midplane or the midline. What's the difference between sine and cosine? Well, sine starts at the midplane and then goes up and then back down for a positive sine theta. If this was negative sine theta, it would start at the midplane and go down and then back up, so that's negative sine theta. But cosine doesn't start at the midpoint, it starts at the peak and then goes down and then up like so. And if you have, that's positive cosine theta. And if you have negative cosine, well then it's going to start at the dip, right, or the minimum, and then it's going to go back up like so, okay? So the amplitude is just how high above the midline you're going to go. So in this case, the midline is just this center that your graph is focused around, that you're going to either go up by or down by. So if my midline is like 3, then I'll have a flat line at y equals 3. And if my amplitude was like 5, then I'll be going 5 above the midline and 5 below the midline as a part of my graph, okay? And the frequency is just how often you have cycles, okay? So one complete cycle of a wave is different when you're talking about sine and cosine. For a sine wave, one complete cycle goes up, goes back down to the midline, goes down to the minimum, and then goes back up like so. So this is one complete cycle for a sine wave, okay? And the distance that it takes for the graph to complete one complete cycle is what we call the period, okay? For a cosine, it looks something like this, right? This is the full wavelength. Oh, sorry, that's physics. This is the full period or full cycle for a cosine wave. So to find the period, that's just 2 pi divided by the frequency. And whenever a problem asks you to graph a line or a wave, that's the first thing you want to do. The Regents will always ask you to graph like at least one full cycle of the following equation, right, or the following line. The first thing you want to do is find the period and set your outermost point on your graph to be that period, okay? So for example, if this was, 6x, then my period would be 2 pi divided by 6, okay? Which would end up being pi over 3. So that means that if I had this axis right here, pi over 3 would be my endpoint all the way at the ends, and I know that, if this again was a sine function, we'd have to go up, down, minimum, and then back up in this measure of space, okay? So essentially a graph is going to, or a sine graph and a cosine graph are going to have 5 key points. So the first point is the starting position, either at the midline or on the midline, or above the midline or below the midline, depending on what type of function you are. This second point is for a sine function is when you go all the way up to your peak. For a cosine function, it's when you're all the way at your bottom, okay? Then for both of these, the second key point is when you return back to the midline, okay? Then the third key point is when you go all the way down for a sine function. And finally, the last key point is when you return to your starting position, which was all the way over here. So there's 5 points. That means that you need to put the actual x value at which each one of these points goes on. So you take your period and you divide it by 4 to figure out the scale, okay? So how do you do that? Just go into your calculator and type in your period without the pi. So in this case, my period is pi over 3. So if I remove pi with 1, I'll just have 1 over 3. If I divide 1 over 3 by 4, I get 1 over 12. So that means that my scale here has to be pi over 12. Okay, so replace everywhere you see a 1 with pi. So pi over 12 is my first increment. Then my second increment is just pi over 12 plus pi over 12, which is 2 pi over 12 or pi over 6. So this is pi over 6. And finally, you have 3 pi over 12 over here, which is going to be pi over 4. And then finally, my period, or the last position here, the last point, is going to be pi over 3. Then you just need to add a certain, whatever your amplitude is above your midline and whatever your amplitude is below your midline, and that's how you get your full graph, okay, for sine. For cosine, it's the exact same procedure, right? You're still going to find 5 points, take your period, divide it by 4 to get the increments, but instead you'll start up here, and your first key point will be the amplitude. Sorry, the maximum amplitude, or like the maximum height, and then you'll go back down to the midplane, and then you'll go back down all the way to your minimum, and then you'll go all the way back up over here and then back up again like so. Okay, so that would be your full complete cycle. Okay, so that's wave and wave graphing reviewed. We just have statistics left, and you guys are, hopefully reviewed in terms of this exam. Okay, so let me just quickly erase this board and I'll get back to you. So oftentimes the Regents will ask you to, calculate a confidence interval, and it's pretty simple how to calculate a confidence interval. You just need to know that 95% of the data fall between plus and minus 2 standard deviation of the mean. So if you take your mean and you add 2 times the standard deviation, that'll give you your outer band, okay? And if you take 2 times your standard deviation and you subtract it from your mean, that'll give you your lower band. And it says that 95% of the data that you get from any sort of simulation or any sort of survey will fall between these 2 points. So if they ever want to ask, oh, what's a plausible range of values? It's always the mean plus minus 2 times the standard deviation. And if a Regents problem ever asks you, well, is this piece of data unusual? If the piece of data is unusual, relies or is determined based on whether it lies within that interval that you determined. So I drew this curve here because that's kind of supposed to represent what's happening here. The mean is the center, and then this bound right here, anything after it is unusual data. Everything after this point is also unusual. So let's say that my standard deviation was like 0.2. That means that my outer band, the biggest that this value or any value that I get can be without being unusual, is 2 times 0.2 plus 4, or 0.4 plus 4, which is 4.4. And the smallest value that I can get without it, being unusual and a part of the 5% of data that doesn't fall within 2 standard deviations, is going to be 3.2. Okay, so if a Regents problem ever asked you, well, Sally received a sample that had a mean weight of 3.1. Is her data unusual? You would answer yes, her data is unusual because it's outside of that 95% confidence interval. Okay, so that's all you have to do here. Okay, so that's pretty easy. The other type of statistical problem that they'll give you is they'll want you to use the normal CDF function on your calculator. So they'll give you a situation where it's like, oh, someone at a company knows that on average, they sell coffee bags, right? And each bag of coffee weighs 4 pounds on average. That's the mean. Okay, so they want to find out, how can I phrase this for you guys? They want to find out what percent of coffee or what percent of bags will be between 3.6 pounds and 4.3 pounds if the standard deviation is 0.3 pounds. So essentially, the difference between these two problems is up here you're being asked to do one of two things. Either you're constructing a range of data, or you're answering yes, this data is normal, or no, this data is strange. For the problem on the bottom here, you're calculating a probability of something happening, or a probability of something falling between a range. So you know that, again, whenever you have this arrangement here, right, this normal curve, if something is normally distributed, this is the only time that you can have, you know, this 95% confidence interval, and it's the only time that you can use this type of you can use this method to solve problems like these, okay? But usually everything on the Regents is normally distributed, so you don't have to worry about that. So essentially, this graph or this curve is going to be centered around the mean, which we already said was 4 pounds. And you're asking yourself, well, what percent of the data, or what is the probability of me selecting a point that is between this interval 3.6 and 4.3, right? How likely will I be to select from here to here? If you always draw it out like this, you draw out your lower bound over here, your mean in the middle, and your upper bound here, all you have to do is move into your calculator, go into second bars, scroll down to normal CDF, and then when it asks you for a lower bound, literally just type in the smaller value, which is 3.6. Okay, so when it asks you for the upper bound, type in the bigger value, which in this case is going to be 4.3. Then when it asks you for this kind of weird u called the mu, you just type in your mean, which was 4. And then this row, which is this kind of I don't know, circle with a hat on it, right? That's your standard deviation. So you just type in 0.3. And if you hit paste and then press enter, it'll tell you a number, right? This number is the percent chance of something being in that range, okay? So it's not actually 0.75%. If you multiply this by 100, it's going to be 75.01%. So 75.01% of bags are going to be found in this range, okay? So that's how you find the percent, or the probability of something being within a specific range. You use the normal CDF function, okay? The margin of error is always plus or minus 2 times the standard deviation. A confidence level is just how confident you are with your data. Usually we use 95% confidence, which is plus or minus 2 standard deviations. You can also use 68% confidence. If they ever ask you to calculate a 68% confidence interval, that's just the mean plus minus 1 times the standard deviation, but that's kind of rare on the Regents. The mean, if you didn't know, was an average. If a set of data is biased, that means that it's likely to be influenced and to be slanted a certain way. If it's unbiased, it's good. That means that it's not going to be slanted in any way. It's going to be normally distributed. The variance is, on average, how much your data will vary, okay, or your standard deviation. Okay, your standard deviation is the spread of the data, right? It's how spread out your data are. It's the average distance between each data point and the mean. Okay, now, surveys are used to gather large quantities of facts or opinions, and surveys are usually asked in the form of a question, right? Observational studies is when the observer does not have any interaction with the subjects and just examines the result of an activity. Finally, a controlled experiment is when 2 groups are studied while an experiment is being performed, with one of them being treated differently, and you're observing the results of that treatment. Okay, so if the Regents ever asks you, oh, what type of study is this? Ask yourself, are they asking questions, yes or no? If they are asking questions, guess what? It's a survey. Okay, if they're asking questions to random people, guess what? It's a random survey. All right, then if you said no to that, well, ask yourself, are the people observing other people, or are they observing something happening? Okay, if you answered yes, then it's an observational study, okay? If you want to be extra sure, are they observing them? Are they observing the phenomena without actually interacting with it? If the answer is yes, guess what? You have an observational study. If you answered no to both of these, and the people in your problem are treating 2 different groups differently and looking at the impact of that treatment, then you're dealing with an experiment, okay? So that's it, right? One more topic we have to go over, and that's just probability, and then you guys are free and can take this test, and that's it. Okay, so when you're dealing with probability, you know that probability is part over whole. Okay, so it's everything that could happen divided by everything that is happening. Okay, so for example, if you're rolling a coin, that could land on either tails or it could land on heads, right? So everything that could happen, there's 2 total possibilities, but only one of these things is happening at the same time. Okay, so to figure out whether 2 events are dependent or not, right, if the probability of 2 events are tied to one another or not, use this formula. P, or the probability of B given A, okay, is equal to the probability of A or B over the probability of A happening, okay? So that's essentially how you find whether two events are independent or dependent. If these two sides are equal, that means that they are dependent. If these two sides are not equal, that means that they are independent of one another, okay? And you might be asking me what this symbol right here means. Well, guess what? There's another equation for you to memorize with that, okay? So whenever you have this downward facing arrow, right, or this downward facing arrow, you know that this can be rewritten as the probability of A times the probability of B, okay? And you're just dividing that by the probability of A, all right? Then whenever you want to find this specific thing right here, you're, again, seeing whether or not the probability of B given A is equal to the probability of A times B divided by the probability of A. Okay, if these are two equal, if both of these are equal, that means you're dealing with dependent events. If they're not equal, you're dealing with an independent event, okay? Remember that for independent events, right, there's just more formulas that you just need to remember for this. These are not on your reference table, so I suggest memorizing them. If you want to find the probability of two independent events happening at the same time, right, or the probability of A and the probability of B, that's going to equal to the probability of A, right, plus the probability of B minus the probability of A and B, okay? Sorry, if you want to find the probability of A or B, you take the probability of A, you add it to the probability of B, and you subtract it from the probability of A or B, all right? If you want to find the probability of A and B, then you just do the probability of A times the probability of B, okay? So this is or, this U means or, and this closed U means and, okay? So the probability of A and B is the probability of A times the probability of B, and the probability of A or B is the probability of A plus the probability of B minus the probability of A and B, okay? And that's pretty much all you need to know about probability here and dependent versus independent tests. The last thing I want to just leave you guys off with is sine, cosine, and tangent, right? Remember the saying SOHCAHTOA. Okay, so sine of theta is equal to opposite over hypotenuse, cosine of theta is equal to adjacent over hypotenuse, and the tangent of theta is equal to the opposite over adjacent, right? So if you have a right triangle, here's a right angle. Okay, the side opposite the right angle is the hypotenuse. This is angle theta. The side opposite theta is the opposite side, obviously, and whatever's remaining is the adjacent side, okay? And essentially, you can solve for sides within a right triangle by plugging in that angle and setting it equal to two sides, okay? Or setting it equal to one side and then solving for the other, all right? And the opposite is the same, right? If you have two sides and you're solving for an angle, you can use something called an inverse function. So you can find inverse sine, which is the opposite of the hypotenuse, and that'll tell you the angle. Or the inverse of cosine will tell you the opposite, or will give you the adjacent over the hypotenuse, and it'll give you the angle. Or the inverse of tan, if you plug in the opposite or the adjacent to it, will again give you that specific theta or that specific angle, okay? Then if you guys ever want to find inverse functions, or, you know, for example, f -1 of x, if you have the function, you know, y is equal to 3x plus 2, and you want to find the inverse, all you have to do is just flip the x and the y's. So just rewrite it as x is equal to 3y plus 2, and now rewrite it as y to get the inverse function, okay? One last thing, even versus odd functions. For an even function, you know that f of -x is equal to f of x, okay? And if this is not true, you're dealing with an odd function, okay? So essentially that's it, right? That's everything that you need to know for the Algebra 2 Regents. I understand that this video was pretty long, but I mean, I don't know. It's kind of hard to cover an entire year's worth of learning in one video, and I've never done these before. Also, odd functions, f of -x is equal to -f of x, okay? So just plug in values to figure those two out. I hope this video was some help to you guys. I hope you guys learned something, and good luck tomorrow on your exam.